Hey everybody, so I've been making these bonfire or solo stove heat deflectors. I guess because of their construction, they don't really radiate heat out, so you lose a lot of heat going up. So people have been having me make these. So this is one that I've basically put together in Fusion 360 to kind of show all the different parts and what it is that we'll actually be making. So this is one I did recently for a customer, where it's got this little buoy up on top. We got the actual deflector top, some legs, and the rings right here. So as I refer to these parts in the video, you get to see how it goes. But for the most part, this base ring will just sit right on top of your bonfire or Yukon solo stove. Fire comes up and it'll deflect out. And I'll show that in a picture on here too as well. So as you can see with the deflectors, they just sit right up on top of the stoves or on the table, and you're gonna have your little fire underneath. Heat's gonna rise, hit the deflector, and basically push out. So it's a relatively simple design. Works, I guess. I think they look pretty cool, so we'll get into making them. Okay, so the first thing we're going to do to make the heat deflectors, we got to cut the top, and then we're going to also cut the logo that goes up on it. So this one that I'm doing is a 27-inch, 27-inch Yukon, and basically it's for some like buoy that a customer wants down for some like resort or some area down in Florida. So we'll get that cut up, and then we'll start making the rest of the parts. So to make all these parts in the deflector tops, I'm using a Langmuir Crossfire Pro CNC plasma table, which I was able to take the file from Fusion 360 and basically import it into this. I have it set up with a machine torch, so you can see that long part where the sparks are coming from. And I've had this machine for about a year now, and it's been working pretty good. So we're cutting these out of the 16 gauge steel that we have there. And it's got a water table underneath to kind of catch some of the debris. And I usually can get the deflector top and the design out on this one part of the sheet. Okay, so the next thing we do is we're going to take those pieces that we cut and we're going to remove the dross from the back of them. So if you see here on the buoy, right, we got some stuff here to clean up, no big deal. So that's the FL Woods buoy roll right there. And then this is the 27-inch deflector top right here. So we're going to remove the dross off the edge of that, clean them up and get those ready. One for ring to get welded on and for the buoy to get powder coated. Removing the dross is relatively straightforward. I use a flap disc with 80 grit wheel on it and kind of able to just go around, and sometimes it plucks right off, sometimes there's not a lot of dross, sometimes a little bit, but you can see it's relatively easy to do. Then I move on to the deflector top. I clean up all with little mounting holes and I give it a quick sanding with anywhere from like 100 to 120 grit sandpaper. Once I have those tops all sanded, then basically I'll use the Evolution cold cut saw and cut some cold rolled steel 1/8 inch to make the rings themselves and these top or the legs that'll eventually go to hold the top and bottom rings together. So you can see here, I just basically mark, cut, and kind of keep on going and repeating the whole way through. Now what I'll do is basically I'm going to take, for the rings, I'm going to take all the pieces that are similar, I'll weld them together so that I can put marks on them with the template you got there, mark them with Sharpie, and once I have this, now those pieces can all be drilled out. Okay, so we have the milling machine right here. Basically, I keep this machine is just dedicated for doing this. I don't really do much else with it, otherwise then I have to readjust the setup. Kind of free, thanks Bill. And I basically use this to drill holes. So it's a giant drill press, just set up to do this. It works nice. So let's get our pieces. And that's it. Now basically repeat this as many times as I normally need to. Bailey ring roller, not sponsored. Maybe one day. Basically with the ring roller,
We're going to slide the metal through, goes through these rings. I adjust the rollers up and down, and it allows me to get the ring that I need. And then we weld the ring together afterwards.
And over at the ring roller, basically just kind of adjust those in, like I said before, and start rolling rings. Sometimes I can get this dialed in pretty quick, and I can bang out a lot of these all at once. Other times, not so much. But usually once I get in the rhythm, it goes relatively easily, and I can get quite a few of these done.
Okay, now what I do is I'll take that ring. I'm going to measure for the overlap I need, because when I do the circumference of them, I usually make them a little bit bigger. I adjust for overlap for the ring. I don't get like a perfect ring or a butt weld. I just do an overlap. It's easy enough. It works all the time. And we'll get those welded up.
So you can see here, I put them down on the welding table, get them marked, clamped, and then I basically just burn in both sides, and I'll just flip and repeat. Just another view. You can see it right from the top, and just a quick mark. Usually I'm doing perfect. There's like a little bit of play in each one, and that's pretty much it. Relatively straightforward process, pretty clean, works. No one said anything to me about the gap or the overlap, sorry, that's in them. So there you have it, pretty easy. So here I have the tabs for the legs that connect the top and bottom rings. They get cut on the plasma cutter as well, and there's draws on them, so I hook them up in my magnetic chuck, and I'm able to clean these up relatively quickly. I can do up to 25 at a time, so it makes for some quick work, that chuck.
So now here's the jig. Basically, what happens is these little tabs rest in here, and here, and then the piece of flat stop goes in right of it. Now remember, it doesn't have to be a perfect size because this jig is spaced. Basically the tabs are what's really taking the brunt of everything, so we'll get these welded up. Basically what I do is I take my grinder, set it up in the vise, and then what I'll do is I'll just basically clean up some of that on here, like so, and then that cleans it up a little bit. So we'll go bust through a few of these. So now a little bit cleaner of an edge right there.
Here I'm just sanding up the rings. They don't fit in my sandblast cabinet too well, so I just go over them with the orbital sander. Now that I have the rings all done, top's all sanded, everything's ready to go, I have these little holes I placed in, that's what I was just pointing at, and those holes allow me to line up these rings. And once the rings are all lined up, basically come over. With the larger ones, I have to put about 6 welds, and with the smaller bonfires, I do about 3. You can see they're getting nice and burned in there.
So there they are welded. You can see right there for the welds going all the way around. Usually I only need 6 for the bigger ones and 3 for the smaller. Then I'll come on flip, and I'll take care of those little holes.
So those little alignment holes, I basically just have to weld them closed right here. That's what I'm doing. So it's just 3 per top, and we just do little welds right there.
Now what I'll do is I'll clean up a few of these spots here, so grind them flat. Now everything's pretty much ready for powder, so let's start getting things cleaned up. We'll get the oven turned on, and we'll get to it. Okay, so what we're going to do now is we're going to powder coat the little buoy, and let's get this on. So basically how this process works is that we have a ground cable here. Ground cable is going to get hooked to the metal frame of the cart. The buoy itself, this is all metal up here. The gun, powder coat gun, has a little reservoir powder connected to it, air line going in. Basically, when I pull the trigger, the air will go into the little hopper, fluidize that powder, and then it'll send it out through here. Where out on here, if we look inside there, there's a very little tip where an electric charge is produced. So then as those particles come pass through that tip, they get charged. This becomes the ground, and those particles are then attracted to it. Then it goes into an oven where it's cured. So basically those little particles are all plastic, little fine particles of plastic. If I was spraying a lot, I would have the respirator on, but it's only this little bit. So basically, you can see. Here's the oven over here. And now we just wait about, I don't know, it's about a couple hundred degrees now. Once it gets up to temperature about 400 degrees, we'll let it sit in there 10 more minutes and be good to go. I'm going to probably throw a couple other parts in there just to make use of that heat in there. Okay, so now we're ready to powder coat the rest. So you can see here, I got the rack all loaded up. I got some legs, a couple other deflectors on there. So let's get this all coated up and into the oven. The oven's preheating right now.
So I usually start these off by doing any of the harder parts first, these rings. When I do the actual deflector tops, there's a Faraday effect in those tight corners, so I'll usually lower the voltage on the gun to get in, or sometimes I will preheat these parts and do what's called like a hot flock on those harder things, and as they cool, I'm able to go in then and increase the voltage and get the rest of them. This is using a high temp powder coat. It's good up to 1100 degrees allegedly. This is one of the processes that I kind of continually play with. And once I finish them up, we get into a 450 degree oven for about 20 minutes. Part metal temperature has to get to 450, and they come out like this.
Okay, so now everything's out of the oven, and we'll assemble. We'll put the top, in this case, this little buoy, up on top of the heat deflector. Let's take a look at that right there. Basically what I use are some stainless steel screws, aluminum standoffs, and some lock nuts. Pretty easy stuff. So we'll assemble that. These aluminums are nice because they have a pretty big surface area to screw everything down onto. Line that up. Like so. Almost there. Two more. is one deflector top, that is for the 27-inch Yukon.
So pretty much now we have all the parts for the deflector. I was going to assemble it, and then it was pretty late, and I forgot. I ended up packing it into a box and sending it out to instead. But in any case, we have all the parts. Inside these holes right here, we get 1/4-20 stainless steel screws and lock nuts, and the same stainless steel screws up here for the spacers that I showed. And that is a completed solo stove heat deflector. If you have any questions, you can email me, comment. This is a process is continually changing as as I go on and make these. It's they're a lot. So hope you enjoyed this. At least you got a run through on how they're made. If you can follow me on Instagram at StanoHacks or Mike's Design and Fabrication, and yeah, drop a comment pretty much anywhere. Have a great day. Bye.